Hello students, good evening all. So hope you are doing well. So again welcome to APJ Academy. So dear students, as you have seen in the thumbnail, today we are going to discuss a new chapter, that is redox reactions, and today we are going to discuss more about oxidation states. Okay, so we will be discussing in detail about the oxidation state, how to find out the oxidation state of the elements in a compound. All those things we will be discussing in this segment. Okay, so I hope your preparation is going well. Okay, so now let's get started. So this is all about our full year course, what we provide. So you can just read it. We provide all the PDF materials that is required for your preparation, complete modules which consist of all the concepts, and also it also has numerous amount of questions. As you all know that if you are preparing for competitive exam, it is an obligatory that you have to do more and more problems. And next we have test series. Along with that, we have 25 major test series as per NTA pattern. Okay, so that will always help you and boost your confidence, as well as it will help you, it will keep you in track with the preparation. Okay, then we have query solving. That's an important part because doubts always arises. So we will provide teachers, or we will have solutions will be provided by the teachers. Okay, and the lessons, we have a complete explanation of the theory will be given to you, and also after each lessons you will be given assignments in order to check the progress, or how you have learned that chapter, whether you have learned that chapter or not, whether you have followed the classes or not. So a strict surveillance will be provided for you, because we have a proper mentorship program where you will be mentored by the experts in the field. Okay, now, and all these we are providing just for rupees 490 per month. That's an enormous discount, and dear students, take this advantages, because you can crack JEE and NEET, and you can join the colleges of your dream with just a small amount of money, right? Okay. Now, if you are watching this channel for the first time, students, you can subscribe to this channel, because I can guarantee you that this channel is going to be a helper. This channel will surely add value to your preparation, because we are providing free content on YouTube channel. On this channel you can subscribe it, as well as you can share this channel if you wish, so that the other students who cannot afford the preparation, who cannot afford the JEE preparation or JEE coaching, so they can come here, learn for free, and they can acquire a very good rank and join their dream college. Okay, so it's obligation on us, whether we are providing a service, so that you have to share this with other students, so that they can also get benefit from this channel. Okay, and this is what or about me, students. You can read what I am, who I am, and my achievements you can read over here. So now I'm not wasting much time over this slide. We are just going straight into the topic, that let's discuss what is oxidation. Okay, students, let's see. You can read the screen. You can read it in the screen, that oxidation, what do you mean by oxidation? Oxidation is the process of addition of oxygen. So is it oxidation is the only process in which we add oxygen, or any other process we can call it as oxidation? Obviously we can call. First of all, you have to understand, if in a reaction you are adding oxygen to a particular element, then we call it the reaction, we call the reaction as oxidation. Only oxidation, only addition of oxygen? No. If you are adding any electronegative element also, if you are adding any electronegative element or a group to a particular atom or element, what you are doing is you are increasing the oxidation state of that particular atom or element. That means oxidation means not only addition of oxygen and not only addition of any electronegative element, but also we can define in this way, in a process where the oxidation number of an electron of an atom increases. Okay, If in a process the oxidation number of an atom increases, then that process is called as oxidation. And another definition for oxidation is removal of hydrogen. We know that hydrogen acts as electropositive element also. It acts like it shows metallic characters as well as non-metallic character, like characters of halogens also it shows, and it shows characters of metals also. So hydrogen removal of hydrogen is also called as oxidation. Similarly, if you are removing or eliminating any electropositive element from a group, that is also called as oxidation. So in short, we can give 4 definitions for oxidation. What are those 4 definitions? The very first one is addition of oxygen is called as oxidation, and addition of any electronegative elements. So you might be thinking, what are the electronegative elements? You can see here, students, F minus, fluorine is an electronegative element, Cl minus is an electronegative element, O minus is an electronegative element, and N minus is an electronegative element. So I'll just rub this in order to remove all these negative charges. In fact, I can give you the elements name which are most electronegative. Okay, yeah. So what are the electronegative elements? You know that the most electronegative element is fluorine, then comes oxygen, then comes nitrogen, then comes chlorine. Likewise, these are the most electronegative elements that we have studied in the periodic classification. Okay, so here you can see, here I have given 3 examples in this slide where you can see the different aspect of oxidation reactions. Here, what is the oxidation number of magnesium? We know that if any element is existing in elemental form, or if any element is existing in its natural form, then the oxidation number of that element or that molecule is considered to be 0. Similarly, the oxidation number of oxygen is 0. Why the oxidation number of oxygen is taken as 0? Because the natural form of oxygen is O2, or it also exists in O3 form also. If you are just taking elemental form or the natural form in which they exist, then the oxidation number should be taken as 0. That we will be discussing on the later slides. Okay, now let's check it here. Here, now it's a compound. We know that mostly or generally we take the oxidation state of oxygen as -2. Here also we will be taking the oxidation state of oxygen as -2. So I want to find out the oxidation state of magnesium. So I put the value X. So what is the oxidation state of magnesium? I can write it as X plus oxidation number of oxygen is -2 equal to charge on the molecule. What is the charge on the molecule? You can see there is no charge on this molecule. Therefore, the charge on the molecule is taken as 0. So X minus 2 equal to 0. So X is equal to plus 2. Now students, you can see here the oxidation state of magnesium in magnesium oxide is plus 2. So what has happened? From 0, the oxidation state has raised to a plus 2 value. That means here the oxidation number has increased. If the oxidation number of any element has increased, then that reaction or that process is called as oxidation. Hope this is clear, students. Hope this is clear. Now you can see in the second example we have FeCl2. Let's check the oxidation state of Fe in FeCl2. So the oxidation state of Cl2 here in combined form is -1. Here what is the oxidation state of chlorine alone? Since it is standing alone, since it is in elemental form, or since it is in natural form, the oxidation state of chlorine is 0. But in the compound form, the oxidation state of chlorine is generally taken as -1. So here you can take it as X is the oxidation state of iron, and X plus 2 chlorine is there. So charge on chlorine or oxidation state of chlorine is -1 is equal to charge on the molecule. The charge on the molecule, there is no charge on the molecule, so it is equal to 0. So X minus 2 equal to 0. That means X is equal to plus 2. So here the oxidation state of iron in FeCl2 is plus 2. Now let's check the oxidation state of iron in FeCl3. In the case of FeCl3, take it as X plus 3 into -1. That is the charge on chlorine. The oxidation state of chlorine in compound form is generally taken as -1. So there are 3 chlorine atoms. So 3 into minus 1, charge on the molecule equal to 0. So x minus 3 equal to 0. So x is equal to plus 3. Now you can see that from plus 2, the oxidation state have increased to plus 3. That means iron has undergone a process called as oxidation, where its oxidation number from plus 2 has increased to plus 3. Now similarly you can see the so in the in the example B, what can you find? See, here you can see that one electronegative element has added to this compound. So what is the electronegative element? I have told you fluorine, oxygen, nitrogen, chlorine and all are electronegative elements. If you are adding an electronegative element, see, you have added an electronegative element here. So what happened? The oxidation state of the iron increases. That means the process is called as oxidation. Here in the first example, you can see that you have added oxygen to magnesium and the compound formed is magnesium oxide. By adding oxygen, what have you done? You have increased the oxidation state of magnesium from 0 to plus 2. Now similarly in the case of H2S, if you react it with chlorine, okay, you react it with chlorine, you are getting an answer as 2HCl, okay, 2HCl. So what is the oxidation state of sulfur here in H2S? So put the value of oxidation state of sulfur as X, and we know that hydrogen in general cases have the oxidation state of plus 1. So 2 into plus 1 plus X is equal to charge on molecule equal to 0. So we can write it as X is equal to minus 2. So oxidation state on sulfur is minus 2. So what is the oxidation state on the sulfur in the product side? Since sulfur is standing alone, since it is in elemental form, the oxidation state is 0. So from minus 2 to 0 means what has happened? From minus 2, a compound or an element, the oxidation state have increased from minus 2 to 0. Minus 2 is a smaller value, 0 is a bigger value. So from minus 2 to 0 means the oxidation state or oxidation number has increased. So if the oxidation number has increased, then that process is called as oxidation. So what has happened here? Here you can see that from H2S, I have removed H2. I have removed hydrogen. So upon removal of hydrogen, the process happened here is called as oxidation. So now we have already explained the oxidation in different terms. That is, if addition of oxygen takes place, then that process is called as oxidation. If addition of any electronegative takes place, electronegative element takes place, then that process is called as oxidation. If addition of if removal of hydrogen takes place, then also that process is called as oxidation. And let's check one more example. Here you can see K2MnO4, O3, H2O, and you can see the product here formed is KMnO4. So what is the difference between K2MnO4 and KMnO4? Here there is 2 atoms of potassium. Here there is only 1 atom of potassium. So all the metals are electropositive in nature. All the metals are electropositive in nature, since they releases electrons. Okay. So all the metals are electropositive in nature since they releases electrons. So from K2MnO4 to KMnO4. So let's check the oxidation state of manganese in this compound and let's check it in this compound. Okay, then we can fix whether it has undergone oxidation or any other process. So from here we know that the oxidation state of potassium is +1. I'll teach you how I got +1 and all. So for time being, let's understand it is +1. So I take it as there are 2 potassium atoms. So 2 into 1 plus X. Oxidation state of manganese is taken as X, and oxidation state of oxygen is -2. So 4 into -2 equal to total charge on the molecule is 0. So 2 plus X minus 8 equal to 0. So X is equal to +6. So the oxidation state of manganese in K2MnO4 is +6. Now let's check the oxidation state of manganese in KMnO4. In KMnO4 we have only 1 potassium plus X plus 4 into -2 equal to charge on the molecule, that is 0. So 1 plus X minus 8 equal to 0. So X will be equal to +7. So here students, you can see that from +6 it has converted to +7. That means there is an increase in oxidation number. So if there is an increase in oxidation number, then obviously the process is called as oxidation. Okay, from plus 6, here it was plus 6 and here it is plus 7. So from plus 6 to plus 7, we know that increase in oxidation state, that means the process is oxidation. So how the process has become oxidation? Here the interesting fact is potassium is an electropositive element. If in the product you can see that there is one decrease in the number of potassium atoms. So you have removed an electropositive element. So if you are removing an electropositive element or any metal, the oxidation state increases. So that is the fourth definition of the oxidation. So coming back to the previous slide, you can again read here that oxidation is the process of either addition of oxygen or addition of any electronegative element or removal of hydrogen or removal of any electropositive element. So hope this is clear, students. If this is clear for you, then reduction is a simple process, because just the reverse of this is called as reduction. So what do you mean by reduction? Reduction means removal of oxygen, removal of electronegative element, addition of hydrogen, addition of electropositive element. So what you have studied in oxidation, just the reverse of it will give you the reduction. Just read the definition of reduction. See, students, reduction is the process of addition of hydrogen. Reduction is the process of addition of hydrogen or any electropositive element or group, or removal of oxygen or any electronegative element or group. So these are the four definitions that suits the reduction. What are they? Reduction is the process of addition of hydrogen. Actually, what do you mean by reduction? Reduction means by means of process you can give all these definitions. Actually, reduction means reduction in oxidation number. Reduction in oxidation number. If after a process the oxidation number of a compound or an element has reduced, then we can say that that particular element or compound has undergone a reaction called as reduction. Is that clear, students? So reduction is the process of addition of hydrogen or any electropositive element or a group, electropositive element or electropositive group, or removal of oxygen is also called as reduction, or removal of any electronegative element or corresponding group. Okay, let's see these examples. You can see that H2, Cl2, in the product it is HCl. I have already told, if you are taking an element in free state, the oxidation number is taken as 0. Here it is in compound state. Here hydrogen, oxidation state of hydrogen is also 0. Now let's check the oxidation state of chlorine here. I'll put it as X. So hydrogen generally shows +1 state. So 1 plus X equal to charge on molecule is 0. So X is equal to -1. So here you can see that the oxidation state of chlorine is -1. So from 0 to -1, what has happened? 0 is a bigger value, -1 is a smaller value. So there is a reduction in the oxidation number. So this process is called as reduction. So how the reduction happened? By addition of hydrogen to chlorine. So when hydrogen is added to an element, what happened to that element? It undergone reduction process. Okay. Urmila Danu, hello. How are you, Urmila? Okay. Now let's check the second example. In the second example, you can see that let's check the oxidation state of zinc here. I put it as X. Okay. So X plus charge oxidation state of oxygen is -2. That is equal to charge on the molecule is 0. So X -2 equal to 0. X is equal to +2. So the oxidation state on zinc is equal to +2. Now in the product side, the zinc is present in the elemental form or in the natural state. So the oxidation state here it is 0. So from here you can see that from +2 the zinc oxidation state has reduced to 0. That means from +2 it has reduced to 0. It means the zinc has undergone reduction reaction. Now let's check into the reaction. You can see that initially there was oxygen and finally there is no oxygen. That means the removal of oxygen has taken place. If you are removing oxygen from a particular element, then you can see that the oxidation number of that element decreases, and we can say that it has undergone the process called as reduction. Okay, it has undergone a process called as reduction. Now you can see in the last case, FeCl3 and H2S. In FeCl3, you can see that the oxidation state of iron is +3, and in FeCl2 the oxidation state is +2. So what has happened? What has happened is that FeCl3, in FeCl3 the oxidation state is +3, and in FeCl2 the oxidation state of iron is +2. That means reduction in oxidation number has taken place. How the reduction has taken place? Since you can see that in the reactant there is 3 Cl, but in the product there is only 2 Cl. That means the Cl is electronegative element. If you are removing the electronegative element from an atom, the oxidation number decreases. That means removal of electronegative element is the process called as reduction. Okay, so this is the definition regarding reduction process. So we have explained in detail what is oxidation. We have explained in detail what is reduction. Now this is the important slide, or this is the important points which you have to study thoroughly, because with understanding this segment you can find out the oxidation states of any compound or any element. Okay, so all the points I have collected and put it in the slide. So you have to study these rules of assigning the oxidation number. So let's check one by one. You can see here, students, these some of the points we have already discussed in the previous slides. So you can see here, if any element is present in free state, then you have to assign an oxidation state or oxidation number 0. See, for example, you can see that the oxidation state of hydrogen, phosphorus, sulfur, oxygen, iron, bromine in H2, like the oxidation state of hydrogen in H2 is taken as 0, because H2 is the free state of hydrogen, or the natural state, natural form in which the hydrogen exists in nature. So in that form you have to take, if you see just hydrogen alone like this H2, you have to take the oxidation state or number as 0. Now phosphorus, if you see it in P4 state, what is the oxidation state number you have to give? 0. When sulfur exists in S8 form, or just simply sulfur, the oxidation state is should be taken as 0. Oxygen in O2 or O3 form, these two states, oxygen exists in nature in O2 and as well as O3 form. So in these two states, it's the free state of oxygen. So free state means without any combination with any other element. See, in O2 only oxygen atoms are present, O3 only oxygen atoms are present, P4 only P4 atoms are, phosphorus atoms are present, hydrogen only hydrogen atoms are present. So that is called as free state. So in all the free states, the element oxidation number should be taken as 0. Now iron exists in the form of iron itself, so its oxidation state is taken as 0. Bromine exists in the form of Br2, oxidation state should be taken taken as 0. This is the very first point you have to remember. Hope this is clear, students. I am not that well, so sorry for the inconvenience caused by creating certain cough. Okay, hope that is not a problem for you. Now the second point is the oxidation state of any cation or any anion is equal to the magnitude of its charge. See, if I say what is the oxidation state of calcium in calcium 2 plus, in calcium 2 plus the oxidation state is +2. What is the oxidation state of aluminum in aluminum 3 plus? In aluminum 3 plus the oxidation state is 3 plus or +3. Or what is the oxidation state of fluorine in Cl minus? It is -1. Oxidation state of oxygen in O -2. It is -2. So in cationic or anionic form, the oxidation state is equal to the charge on the atom or charge on that ion. Okay. Now let's move on to the third point. See, this point also we have discussed in the previous slide, that is the algebraic sum of the oxidation numbers of all atoms in a neutral compound is equal to 0. What does that mean? See, if I take a compound as HNO3. So, in HNO3, I can say that oxidation number of hydrogen plus oxidation number of nitrogen plus 3 into oxidation number of oxygen. All the sum will be equal to the charge on the molecule. See, you cannot see any charge on this molecule. If there is any charge, the charge will be given as like this, -3 or something like that. Okay. So, here there is no charge. So, if there is no charge, then you can equate this with 0. Okay. So, if you are considering a neutral compound, then the oxidation number of all the elements in that compound, if you take the algebraic sum, then you will get the value that is equal to the charge on the molecule, that is charge on the neutral molecule is 0. So, that will be equal to 0. Okay. Now, see the next question. See the next point. The algebraic sum of the oxidation numbers of all atoms in an ion such as PO4 3- is equal to the charge on the ion. That's what we have discussed. See if in the case of PO4 3-, what will be how we can represent the oxidation number? We can say that the oxidation number of phosphorus plus 4 into oxidation number on oxygen will be equal to -3. Since it is 3-, we have to take it as -3. So, let's check the oxidation state of phosphorus in this compound. So, we'll take for time being, we will take X as the oxidation number of phosphorus. So, X plus 4 into oxidation state of oxygen is generally -2. So, I'll take it as -2 equal to charge on the molecule is -3. So, X minus 8 equal to -3. So, X equal to +5. So, in this case, the oxidation state of phosphorus is equal to +5. Now, the next point is, see here from this point onwards, we are going to study about the oxidation numbers of each element. So, oxidation state of alkali metals is +1. So, dear students, what are alkali metals? Lithium, sodium, potassium, rubidium and cesium. These are the alkali metals, and all these alkali metals have oxidation state as +1. And that of alkaline earth metal is taken as +2. So, all the alkaline earth metal we give it as +2. So, Be beryllium, magnesium, calcium, strontium and barium, we give the oxidation state as +2. So, from here you almost got the oxidation states of 10 elements, that is lithium, sodium, potassium, rubidium and cesium is +1, beryllium, magnesium, calcium, strontium and barium as +2. Now, the next point, you can see that hydrogen in almost all of its compounds is assigned as oxidation state +1. So, there is an exception in the case of hydrogen. That means in hydrides, like metal hydrides, so when hydrogen comes with a metal like potassium hydride, sodium hydride, magnesium hydride, calcium hydride, in all these cases the oxidation state of hydrogen should be taken as -1. Okay. Except from this, except from hydrides, in all the other cases the oxidation state of hydrogen is +1. So, with the exception you have to study. So, hydrogen in HCl you have to take as +1. Hydrogen in H2SO4 you have to take as +1. Hydrogen in water you have to take as +1. Hydrogen in HBr you have to take as +1. Except in KH, NaH, MgH2 and CaH2. And remember the name CaH2, there is a common name for this compound, that is called as hydrolith. It has been asked in the previous JEE also. Okay. Next question, next point is, oxygen in almost all of its compounds is assigned as oxidation state -2. So, in the case of oxygen also we have exceptions. So, the oxidation state of oxygen in all the other compounds, in all compounds of oxygen is -2. But if you are considering peroxides, the oxidation state of oxygen is -1. If you are considering the case of in OF2, the oxidation state of oxygen is +2. In the case of O2F2, the oxidation state is +1. In the case of KO2, the oxidation state is -1/2. So dear students, you have to study all these values. So oxidation state of oxygen in general, it is -2. But in the case of peroxides means H2O2, Na2O2, etc. There the oxidation state of oxygen is taken as -1. Okay. Now in the case of OF2, the oxidation state of oxygen is +2. In the case of O2F2, it is +1. And in the case of superoxides like KO2, RbO2 and CSO2. These are the three superoxides of alkali metals. In all these cases, the oxidation state of oxygen is -1/2. Apart from these elements or apart from these compounds, the oxidation state of oxygen is -2. That is what you have to remember. Okay. Hope this is clear, students. Shall we move on to the next one? Yes. Yeah. Fluorine. Fluorine, as you all know, that fluorine is the most electronegative element. Okay. And it is assigned an oxidation state of -1 in all its compounds. See, for other halogens also, oxidation state is generally -1, except in two cases. When they are bonded to more electronegative halogen or oxygen. Like, I'll give you an example. If you take the example of IF7, see, fluorine is more electronegative than iodine. So we cannot take the oxidation state of iodine as -1. No, we put it as X, and oxidation state of fluorine is always be -1. So X plus 7 into -1 equal to 0. So here we get it as X equal to +7. So in this case, oxidation of iodine is +7. Similarly, if you here 2 points you have to remember, that is when they are bonded to more electronegative halogen or oxygen. If they are bonded to oxygen also, there is an exception. That means they do not show the oxidation state -1 in these two cases. So for that, I'll take another example of KClO3. So in the case of KClO3, we know that the oxidation state of potassium is +1. We have already discussed that. Oxygen is -2. And just put it as X for chlorine. So 1 plus X plus 3 into -2 equal to charge on the molecule is 0. So X minus 5 equal to 0. X is equal to +5. So these are the points which will help you to solve numerous questions regarding the oxidation states. Okay. Now let's do some problem. With that, we can wind up the session. So find the oxidation number of sulfur in H2SO4, H2S2O7, H2SO5. Find the oxidation number of nitrogen in HNO3, NO2, NO3 2 minus, NO3 minus, NO3 minus. So let's solve these questions, and also let me give you another one more question. Find the oxidation number of sulfur in SO4 2 minus. So let's do these three questions. Okay, so starting with H2SO4. For H2SO4, you know that the oxidation state of sulfur should be taken as X. Here it is +1, here it is -2. So 2 into +1 plus X plus oxidation state of oxygen is -2. So 4 into -2 equal to charge on the molecule is 0. So 2 plus X minus 8 equal to 0. So X minus 6 equal to 0, X equal to +6. Similarly, H2S2O7. In the case of H2S2O7, you can take it as 2 into 1 plus 2x plus 7 into -2 equal to 0. So 2 minus 14 plus 2x equal to 0. So 2x is equal to 12, x equal to +6. This also value of x is equal to +6. Now what about H2SO5? H2SO5. Here you can see that hydrogen 1 into 2, that is 2, plus x minus 10 equal to 0, x equal to 2 minus 10, that is -8, so x equal to +8. So actually here it is an exceptional case. There is a peroxide linkage in this structure, so I am going to rub this because this is an exception case where you should not find out the value like this. Okay, that we may be discussing later on, certain exception case in that area. Okay, so H2SO5 actually you cannot do by normal solving because there is peroxide linkage in H2SO5. If peroxide linkage is coming, you have to take the oxidation number of that oxygen as -1. You know that, right? So sorry, -1. So you cannot take it as -2. Wherever the peroxide linkage is present, the oxygen in the peroxide linkage should be considered as the -1. Okay, oxidation state of the peroxide linkage, oxygen in the peroxide linkage is -1. So let's do the next one, that is HNO3. In HNO3 1 plus x plus 3 into -2, that is equal to charge on the molecule, that is 0. So 1 plus x minus 6 equal to 0, x is equal to +5. So in this case you can see that the oxidation state of nitrogen is +5. So next we can check NO2. In the case of NO2, you can see x plus 2 into -2 equal to 0, that is x minus 4 equal to 0. So x is equal to +4. Now the last one is NO3 minus. In the case of NO3 minus, you can see that x plus 3 into -2 equal to, charge on the molecule is minus means -1, so you have to put it as -1. So x minus 6 equal to -1, so x is equal to +5. So here it is +5, NO2 case it is +4, NO3 minus it is +5. Okay students, we have one more question. Let's do it in the next slide. So here you can see that SO4 2 minus, you have to find the oxidation state of sulfur in SO4 2 minus. SO4 2 minus. Put it as x plus 4 into -2 equal to -2. So x minus 8 equal to -2. So x equal to +6. So dear students, hope this is clear for you, right? So we will be doing some more problems in order to clarify the concepts. So let's do some more problems. Practice some more problems. Okay. Here you have to find the oxidation number of phosphorus in H3PO4, H3PO2, H2PO3 and PO3 minus, PO3 2 minus. So let's do this together, starting with H3PO4. So how to find out the oxidation state of phosphorus in H3PO4? You know that 3 into oxidation number of hydrogen plus X is the oxidation number of phosphorus, we'll put it as X, plus 4 into oxidation number of oxygen. That will be equal to the charge on the molecule is 0. So you can equate it with 0. Oxidation number of hydrogen is normally plus 1 except in the case of hydrides. So 3 into 1 plus X plus 4 into oxidation state on oxygen generally is minus 2 equal to 0. So 3 plus X minus 8 equal to 0. So X minus 5 equal to 0, X equal to plus 5. Similarly, now H2PO3 minus. In the case of H2PO3 minus, 2 into 1 plus X plus 3 into minus 2 equal to minus 1. So 2 plus X minus 6 equal to minus 1. So X minus 4 equal to minus 1, X equal to plus 3. Now let's check the last one, PO3 2 minus. PO3 2 minus. In PO3 2 minus, you can put the oxidation state of phosphorus as X. So X plus 3 into minus 2 equal to minus 2. Since the charge on the molecule is minus 2. So X minus 6 equal to minus 2. So X is equal to plus 4. So here students, we have almost covered all. There are some more elements missing. So I am going to give you somewhat elements like KNO3, like potassium, sodium and all. So if you can do that also, then everything will be over by that. Okay. So let's do certain compounds with alkali metals and alkaline earth metals. Like I'll give you some compounds like BeCl2, MgBr2, NaOH, NaCl, NaNO3, KNO3. So let's check the oxidation state of all these compounds. You have to find the oxidation state of metals. Actually, we cannot say the metals. Metals is always, we have fixed it, like for alkali metals the oxidation state is plus 1. So we are going to give the oxidation state of each element in each all the compounds. Okay. So in beryllium chloride, we know that beryllium is from group 2, its oxidation state is plus 2 and oxidation state of chlorine is minus 1. In the case of magnesium bromide, the oxidation state is plus 2 and oxidation state of bromine is minus 1. If you have any doubt regarding the oxidation state of halogen, you can just check it, because beryllium, magnesium, sodium and potassium all are fixed. They are not going to change. The oxidation state of all these alkali metals and alkaline earth metals is given in the first 2 points of the previous slides, where we have mentioned what all are the oxidation states of the elements. Okay. So let's check the oxidation state of bromine here. We know that magnesium has oxidation state plus 2, and here I will put it as 2x, because we are finding the oxidation state of bromine equal to 0. So 2x is equal to minus 2, so x equal to minus 1. Now in the case of NaOH, Na it is plus 1, oxygen it is minus 2, hydrogen it is plus 1. Sodium it's plus 1, fluorine it is -1. In the case of NaNO3, let's find the oxidation state of nitrogen. Okay, so we know that sodium has oxidation state as 1. Want to learn about software engineering. Legend game Ghulam Mustafa. You can, if you are serious in software engineering, then the best spot to learn software engineering is IIT Bombay. So IIT Bombay is the best institute in India where you can study computer science engineering as well as software engineering, because the major companies like Google, Twitter and Amazon, like all these major companies comes to IIT Bombay where they do their recruitments. Okay, so if you are seriously into looking into software engineering jobs, you have to seriously prepare for IIT JEE exam, and you have to crack it, not only mains but also you have to crack advanced with a very high rank. Okay, if you can do that, then obviously you will be selected to IIT Bombay, and where you can study software engineering in detail. Okay, so oh, you are from Pakistan. Oh, in that case I cannot help, but you can do one thing, that Ghulam Mustafa, that is you can like there are other outside colleges like Massachusetts Institute of Technology, there are Harvard University, there is Cambridge University. If you are wishing to go and study outside Pakistan, that's a better option, because I do not know much about the education system over in Pakistan. So it will be better if you can go to European countries where you will get a better exposure, you will get a better options to learn software engineering. So these Massachusetts Institute of Technology, Harvard University, Cambridge University, all these universities are one of the best or the top class universities in the world. So you can learn software engineering from these institutes, and you can be a very good software engineer. Okay, so for that, what you have to do is that you have to understand what are the admission processes in these colleges. Okay, so you have to Google search that, you understand what all are the procedures that you have to apply. Okay, so understanding that, you can give the test or the examination which is provided by these universities, and if you score good marks, you will surely get the scholarship to study from these universities, and always prefer to study from these universities if you are preferring to go out. And if you are asking about Pakistan, the internal institutions in Pakistan, I do not have much idea regarding that. Okay, Ghulam, right? Ghulam Mustafa. Okay, now NaNO3. I know a person with the same name who lived long years back. Name was Ghulam Rasul Rajigi. Okay, so welcome Mustafa. Now coming back to the topic, now NaNO3. In NaNO3, we have to find out the oxidation state of nitrogen, that is the oxidation state of nitrogen. So sodium, it is +1, plus oxidation state of nitrogen is taken as X, and oxidation state of oxygen is taken as -2. So 3 into -2, it is equal to 0, and 1 plus X minus 6 equal to 0. So X minus 5 equal to 0, X is equal to +5. And in the case of KNO3, same thing. In the case of KNO3, you can do the same thing, that is 1 plus X plus 3 into -2 equal to charge on the molecule, that is charge is equal to 0. So 1 plus X minus 6 equal to 0. So X minus 5 equal to 0, and X is equal to +5. Okay, students. So this is all about the oxidation state or calculation of the oxidation number from this topic. Hope this is clear for you. Okay, right. Now I want to give you a special advice, that I know you are many of you are going to write exam, JEE exam in the coming week. So I wanted to tell you that we have done a detailed analysis of the previous session question papers. So you can see it in the JEE channel, and you have to analyze all those papers, and we have prepared all the slides in detail and given an detailed explanation on what to do. Okay, so also we have figured it which all are the most important chapters you have to focus on the next session. So like P block elements, from P block elements, from 12 question papers that have 12 taken place from the that have came in the June session, 12 papers. In from that 12 papers, almost 20 questions have asked from P block elements of the second year +2. So P block is very important. General organic chemistry is very important. Coordination compounds very important. Then chemical bonding very important. Chemistry in everyday life very important. 13 questions have asked from that side, from that chapter. So you have to prioritize the chapter, and if any of the chapter which I have mentioned now, if you are not well versed in those chapter, give more importance to that chapter and study it well, revise it properly, so that you can score better marks for the upcoming JEE mains exam. Okay, so that's what you have to do. So hope the topic is very clear for you. We'll meet in the next class, and thank you students for watching.